am Alexis Duha.
I'm Jerry Clark Totor.
I am Joshua Aragasi.
And I am Christian Palma.
Good morning, everyone. Today, we will discuss about the Archimedes principle and its application in maritime transportation. Understanding ship displacement and draft is fundamental to naval architecture and safe maritime operations. These two concepts are intrinsically linked and crucial for efficient and safe vessel handling. Displacement refers to the weight of water a ship displaces when afloat, directly to equating the ship's total weight, including its hull, cargo, crew, and fuel. Draft, on the other hand, is the vertical distance measured from the waterline to the bottom of the ship's hull, a measurement that varies depending on the vessel's load and density of the water. While seemingly simple, the precise calculation of both often requires specialized software and expertise. That's all. Archimedes' principle underpins the concept of displacement. A floating object displaces a volume water equal to its own weight. Therefore, a ship's displacement is a direct measure of its total weight. This weight is usually expressed in tons, metric tons, or long tons. Draft, typically measured in meters or feet, is a critical parameter for navigation, particularly in shallow water or canals. It's usually measured at multiple points along the vessel, forward and midships, to account for variation in hull shape and load distribution. A heavier load naturally increases a ship's displacement, leading to a greater draft. However, for vessels with complex hull designs, accurate calculation necessitates advanced techniques and specialized software.
In summary, displacement and draft are essential parameters in maritime operations. Displacement representing the weight of water displaced and equal to the ship's total weight, and draft, the vertical distance from the water line to the hull's bottom, are inextricably linked. Understanding the relationship is crucial for ensuring safe navigation, maintaining stability, optimizing cargo capacity, and improving fuel efficiency. While simplified calculations can be performed for basic hull shapes, accurate determination for most vessels requires sophisticated methods and computational tools. The importance of these parameters cannot be overstated for the safe and effective operation of the ships.
The key concept is buoyancy. Buoyancy is the upward force exerted on an object submerged in a fluid. It's this force determined by the weight of the displaced fluid, the opposed gravity, and determined whether an object floats or sinks.
Buoyant force. This is the upward force exerted by the water of the submerged portion of the ship hull. It's a direct consequence of Archimedes' principle, but the buoyant force is equal to the weight of the water displaced by the ship. Weight of the ship is the downward force due to gravity acting on the intermass of the ship, including its whole cargo, crew, and everything else on board. The buoyant force, a result of Archimedes' principle, is the upward force exerted by water of a ship hull, while the weight of the ship, including weight of the ship, downward force due to gravity. The difference between these forces determines a ship's stability.
Archimedes' principle. Archimedes' principle states that the upward buoyant force of an object submerged in a fluid is equal to the weight of the fluid that object displaces. This means that the water or any fluid exerts an upward force on a submerged object that is equal to the weight of the volume of water objects pushes out of the way. This buoyant force determines whether an object will float or sink.